Hello, I'm just going to stoop down a bit and talk about the setup that I've gone through to prepare for gear cutting on this Aciera F1 precision milling machine, small precision milling machine. I'm going to be doing a ratchet wheel blank and turning that into a two-way ratchet wheel. Gear cutting, essentially, in clockmaking we call it wheel cutting. It's brass, so it's wheel cutting. Steel would be pinion cutting with much smaller tooth count. Anyway, I'm now going to just run through some of the preparation I've done. I've changed the machine over to be in horizontal milling mode, so the cutter will be in that orientation, and that will allow me to bring this dividing head horizontally across on the traverse. And normally that would be on traversing on the handle there, but because there's so much to and fro, particularly once you start dividing for a number of different teeth, I've changed the milling machine over to lever feed. So now just quick and easy to draw that across. You disconnect the feed nut in order to do that, and I'll talk about that in a moment. At this stage, my primary objective, and the reason I've changed over early to the hand feed, is to set this up so that this dividing head is disposed truly in the same orientation as the horizontal traverse, because this is rotatable. It's also tiltable on this universal holder. There's a couple of little set screws in the end there, and when you release those, they release the tension on T-nuts that act in curved paths behind that. So you can tilt that over, I can't remember how many degrees, 45 degrees, you can tilt it either way. It has a nice little location detent. That's very accurate, so I don't need to worry about that. I've clocked that previously and I know it's dead reliable. But on a previous job, I have had this twisted in order to get a variable depth of cut. So I need to double check that it's now back to zero. There's a scale on here, and nominally zero is pretty good, but it's not spot on, I have to say, on this machine. I've already clocked this in because there's a stage in this that is a bit fiddly, because in order to rotate this, you have to undo those two, and they act on a spigot on the dividing head, much like the one on this inclinable table. So that spigot just drops into the universal head. In this case with the table, you can then tilt it fore and aft and hence sideways as well on that. So that's the principle of the holding there. But when you undo those, you do introduce a little bit of slack into everything. So it's not quite as straightforward and quick and easy to clock as it might be. So I've already done that just to prove that I can actually clock things in accurately. And I'm also going to zoom in so you get a better view, hopefully, of the machine. Probably see less of me, and that can only be a good thing. And so if just bear with me, I'll just zoom in. So hopefully you've now got a better view of what's going on. I'm going to, because the camera's on a tripod and I really don't want to try and move that accurately, I'm going to cheat and try and move the milling machine round instead to talk about things. So as we spin it round, I'll talk about different stages of what I've done. That, as you can see, is the dividing arrangement, and I always mark those up with dots so that I don't inadvertently divide the wrong amount at any stage. That's the disengaged feed screw for the horizontal traverse. If I rotate it round more, you may or may not be able to see, in there's a little set screw, something to point with, so I'm not obscuring it. In there's a little set screw that releases the feed nut. As you can see there, it's now withdrawn, and you'll see that bobbing to and fro. So what you do is you move the table fully to the left before you disengage it, and you refrain from spinning that around, because if you change the position of that by any large amount, you'll end up with less traverse available when you reconnect everything. I've set a stop up so that I don't put any pressure onto that feed nut when I did the initial release, and there's a stop set at the other end so that I don't run the tailstock or the headstock of the dividing arrangement into my dial test indicator. So I said that's now disconnected. And if I spin everything around a bit further, you'll see there's a shaft that you can put a lever on to bring the head backwards and forwards if you want lever feed on that. I don't in this job, so I've left that alone. That is the table lock, so that's disconnected so that I can move the table. I've set a stop, as I said. I've put a handle, or the handle, because it's the right one for the job, onto this arbor here, and this contains the pinion that acts on the rack on the back of this work holding table. So that's the working part of the lever feed mechanism combined with the gear in there. Bring it further around, that's the lock for the work head. Move it around further. Hopefully you can see I've set the dial gauge so that it touches on the back of this support arm, and what I've done is I've brought the work up so that that's on the centre line of this. I'll just show that in a moment. Basically all you do is bring the work table up and down, watching the dial test indicator as you do it to get the high point. So more of that in a moment. So I'll continue spinning it back, cabling out the way. As you've probably gathered, the cabinet for this, whilst it's very heavy, I have put it onto casters so I can move it around the workshop. But I've inadvertently run over the cable. Right, hopefully that's back to a reasonable view of the machine. So, as I said, the idea is to get the dial test indicator, God, I can't think of the word for it, but the little ball head there on the centre line. So the way I've done that, this is just bringing the work table up and down relative to the head. So you look for the high point, there it is, and then see where it drops off. So that handle is horizontal at both of those points, so just half the difference, and that should be securely on the high point. Then, as I said, look, I'll just knock it out of true so that excuse me, I can mimic the situation if I can find the Allen key to fit. I put it down and forgotten where I put it. Bear with me, I'm just going to duck across and grab another one. Yeah, there we go. So as I said, these work on that spigot, well, this clamping does. So as I rotate that, you can see the movement. So it's now set off, excuse me, so that's too far in towards the machine. And it's getting worse, as you'd expect, because the pivot point is there roughly. So I need to draw that back towards me. And I know it needs to go to zero. Obviously, normally you'd be looking for a 0 point as you do this. But as you can see, as I tighten that up, it is drifting one way or another, and I've lost it. It's not bad. I've just changed the 0 point and moving it all around. That's actually pretty good. So you can see the sort of process of arriving at a point where you're happy with that. So now that means that that is correctly disposed 4.5 or in its rotational axis. And that's really what this was going to be about, just describing the early part of the setup. Next I'll get the cutter involved. That needs to be on the centre line of this, and I'll probably come back and talk about that separately. Thanks very much for watching.